The What's Neat This Week video podcast is supported by enthusiastic model railroaders just like you.
These are anyway.
And by Intermountain Railway Company, where the detail makes the difference. Check out their website at intermountain-railway.com.
Additional support is provided by Spring Creek Model Trains, your destination for model trains. Stop in and say, wow. Check out their website at springcreekmodeltrains.com.
Additional support is provided by Yelsma Graphics, America's leading distributor of quality railroad art and embroidered clothing since 1985. Check out their website at yelsma.com. Further support is provided by the NCE Corporation, the power of DCC. Visit their website at ncedcc.com. And thank you for supporting the What's Neat This Week podcast. This is the What's Neat This Week in Model Railroading video podcast, show number 279.5, special edition show. This week I want to share a video with you that I created back and ran it in Model Railroad Hobbyist Magazine's YouTube site, March 2017, What's Neat. Now, the What's Neat show is a show where we get our hands dirty and build things and create things and do layout interviews. It's very different from the podcast where we've got the podcast crew and all of our special guests. On this show, that month, I shared how I lit the Hyde pulp mill from BTS. That was a laser kit that I also showed how I built on a previous What's Neat show. But on this show from March of 2017, I want to share with you how I lit the entire diorama. It was a project where I used the Woodland Scenics just plug lighting system for the very first time, and I was quite interested and impressed and enthusiastic about the whole project. It was a lot of fun to do. The results on it are fantastic no matter where you choose to put them on your layout. So this week I want to share that video with you. I've also got some news from Spring Creek Model Trains in that they are doing a re-release of this beautiful Rock Island car in N scale. That was made by Intermountain. We shared it on a previous podcast, but they're re-releasing that car because it's sold out so quickly. They're also having a Free-Mo event in Deshler, Nebraska. That's going to be July 13th and 14th. That's just around the corner. You can check that out by going to the Spring Creek website. Check that out. And with that now, let's continue on with the rest of this July 1st special edition What's Neat, lighting this beautiful scene on my layout. For this segment of What's Neat, we're going to look at the new technology in HO scale offered to us modelers now of LED lights, and it's HO, O scale, N scale, all scales. This applies to all scales this month. And LED lights have finally come to the modeler through a new system that Woodland Scenics has introduced called the Just Plug system. And I've made a bit of an investment in that because I'd like to light up my wharf scene and actually all parts of this layout using these new LEDs, because the track record that we've discovered so far with LEDs is they seem to last forever. And for years I used the old German beautiful lamps in the Midwest Valley Modelers layout, and it just became a fact of life that about every 6 to 8 months I would have to go through the layout and replace all the old burnt out light bulbs. And the new LEDs should eliminate that problem for us on our layouts. In fact, the way the Woodland Scenics system is designed, I know this for a fact after looking into it, that this is going to give us good filtered power for our lights. So let me show you a little bit about what I went into on this. First of all, my experience with LEDs is they usually light up at about between 2 and 3 volts. And so I thought I was going to be a know-it-all on this project and be able to just simply wire up these lights to a DC power system of about 2 to 3 volts and run my layout on it. And I verified this by hooking up a power pack, a rheostat train power pack, to the lights, and I discovered that as I turned the power pack knob up, the light started to light just around almost 2 volts. I then verified this fact with 2 DC batteries, and I connected those to the LED Woodland Scenics light, and sure enough it lit just fine with 3 volts from 2 batteries. But the more I looked into the system and the more I discovered about a lot of the thought and the electronics that are actually inside the light bulb system, I've decided against wiring directly and instead using the Woodland Scenics system the way it is designed to be used. And I'm going to explain that a little bit further here next. First of all, I've got a bunch of lights here, and I want to explain to you what I've got. I've got the double lamppost lights, I've got arched cast iron lights, I picked up some wooden pole lights, which I think will look really good in the wharf scene. I also picked up some metal modern looking lights, and then some single lamp posts that look really nice. And I also picked up some gooseneck lamps that are attached to the side of the building, so that'll be another feature. And I've also got interior lights where we can light up the inside of the buildings using the Woodland Scenics interior lights that they've already got pre-wired for us. And basically how the system works, and I'm going to show it to you here what I've got hooked up here. The system runs off of an AC power supply, and I've got the power supply connected into this light hub, which has got 4 potentiometers on it, which will allow us to adjust the lighting value of each set of lights. So I've got the Woodland Scenics AC power system plugged into the light hub right now, and all I've got to do is plug in the lights into these jacks that are controlled with the potentiometers, and you can see this interior lighting lights up real nice, this light right here. And then to adjust the lighting, I turn the potentiometer with a screwdriver and I can adjust it bright or dim. I like that feature, especially for lighting the inside of buildings so that the light doesn't actually protrude through the cracks and the corners of the building. Here's a regular street lamp. This is a gooseneck lamp that I've got, and I'm going to plug that into the system here. And as you can see, this lights up real nice. Now let me explain to you a little bit about what they've done with regards to the design on this system. I looked at the light hub here, and as I said, it's got a power supply of AC power going into it, supplying a good 18.3 volts into the light hub of AC. The more I looked into the light hub itself, I avoided my warranty so you don't have to by looking at the inside of this, and I discovered that there's a capacitor in there and a rectifier in there, and a lot of electronics that filter the current to our lights. What the capacitor and what the rectifier does is it converts the AC power from this power pack to a nice smooth DC current of about 16 volts, and I verified that by using the meter on that. I then further followed up with the meter, and I wanted to find out what the voltage was that was being fed to the lamp itself. And it turned out that this was about 3.1 volts, very filtered, very clean current. And that is because on the end of each one of the lighting terminals here, there is a capacitor built, or not a capacitor, a resistor built into this, so that it converts the power from 16 volts DC down to just around 3.1 volts. So it's going to be a very smooth, filtered current, which will ensure the fact that these light bulbs are going to last a lot longer. Now, this unit, you can hook up 3 lights per hub, which allows me to connect 12 lights to the system. If I want to add more, what I do is I take something called the expansion hub, and I plug my power system into that. And then what I would do is I would daisy chain from this to the light hub, and I can add 1, 2, 3, 4 more light hubs to the expansion hub, which means that the end result is I could power by adding 4 more of these to the system. So I can see by daisy chaining this and making it work as per the instructions, and I'll show you the instruction sheet here, which illustrates exactly what I'm talking about, the daisy chaining of the system. We could add as many lights as we want as long as we don't exceed the 1000 milliamps that the AC power supply puts out. And each one of the boxes of bulbs are clearly marked with how many milliamps, 30 for example with this one, that each set takes. So it's easy to figure the math on that. So at this point, what I need to do is figure out how to install all of this into a modular layout, which is what mine is. And my layout is designed whereas I've got to be able to take it outside. So I've got to set this whole system up where I can take it outside, unhook things very quickly, but yet still be able to wire everything up the way it's supposed to. And I've made a cross-section of my layout here to illustrate this, how I think I'm going to connect this up to the wharf scene on the layout. I'm going to put my expansion hub in the bottom, and the reason for that is I can plug my AC power supply directly into that, unplug it and just remove the entire module from the area of the location where it is with a simple plug of the AC power supply. Once I get the power into the expansion hub, I'm going to run the wires up to the light hub, whereas I'll then have power to this. Now, my diorama is built on a 3/4 inch piece of plywood, which is represented by this small piece of wood right here. As I take the diorama up out of the foam module, I'll then have access to the light hub. I'll be able to wire all of my lights up to 12 on this one, and if I had 24 lights all the way across. And then I'll be able to put the diorama right back on top of the light hub, which will be carved out into the foam. That way everything's self-contained. I can still take my modules outside for photography, but yet I've got the entire light hub system worked into it the way it's meant to be, so that I'll ensure that I'll have filtered, smooth current to all of my light bulbs, which would mean longevity, great longevity with these lights. So at this point, what I need to do is I need to go over to the layout, and because the diorama is built on a piece of plywood, I can easily lift that up out of the layout, put it somewhere safe, and then I'm going to unplug everything and undo all the track and pull out the entire module of the layout so that I can get to it from all three sides as I install and cut and wire this up. I'm not exactly sure how I'm going to wire this up, but let's kind of follow with me on the next few steps of this process. It should be easy, it should be quick. It's just a matter of drilling holes into the plywood, installing the lights, wiring everything up to the hubs very quickly, and it should be a very dramatic result on the diorama. So let's do this. Let's dig into it, and let's see what happens next for the install process of this on my foam removable layout. I started this project on the wood dock. This part of the water scene is not removable. I made marks with a pencil where the lights will be installed, working my way along the dock until I had 7 light placement locations evenly spaced. Using a 3/32 inch drill bit, I drilled 7 holes through the wood planks and the plexiglass subbase that make up the dock. Using a 10-inch long 3/16 inch drill bit, I drilled horizontally through the foam under the dock and the railroad tracks, creating a channel to run wires. I pushed a 1/8 inch diameter brass tube through this hole that will act as a temporary conduit to feed the wires through. The Woodland Scenics lights come with a generous length of wire attached, measuring over 3 feet long. I had fed the light wires through the wood dock and then through the brass tube, where it will converge with the light hubs underneath all the buildings. Simply pull out the brass tube and the wire stays in the foam where we want it to be. I took my time on this, working my way along the dock, installing and running the wires through the scene until I had 7 lights installed along the dock. This is the auxiliary switch for the just plugged lighting system. It connects to the hubs by removing the control port wire and plugging the switch's wire lead into the control port. This gives us an on and off control of the lights when everything is installed into the layout. The rocker switch matches the ones I already used to control my blocks on my layout, so I decided to disassemble this one, removing the rocker switch from the housing and finding a place to mount this switch on the side of my layout. I drilled a 3/4 inch hole through my oak fascia and installed the Woodland Scenics rocker switch into this hole by simply pressing it firmly into place with my thumbs. Looking at the layout from underneath, I used a Sharpie to draw a square where the light hubs will be installed. I also drew a line from the auxiliary switch location to the square where I will run the wires. Using a box knife, I cut a slot into the bottom of the foam where the wires will run to the hubs. I used a screwdriver to press the wires up into this slot, embedding the wires permanently into the foam. I used a hot foam cutter to cut a hole in the foam where the wires and the light hubs will be installed. I also cut a hole in my plywood tabletop to match the same area where the hole was cut into the foam. I used Gorilla Glue to attach 2 light hubs side by side on a piece of plywood. The expansion hub was also attached to its own piece of 1/4-inch oak, setting this aside until the glue cured. The 2 light hubs will be glued flush into the foam facing down, whereas I will have access from underneath the layout to adjust the potentiometers with a long screwdriver when it comes time to set the lighting's brightness. Using a hot foam cutter under the layout, I cut an additional space to install the expansion hub facing up, flush with the bottom of the layout. After the glue cured, I plugged the AC transformer into the expansion hub, along with the rocker switch connecting plug and 2 connecting cables that will run to each of the light hubs. I plugged the connecting cables into each of the 2 light hubs. I twisted the fine wires, grouping 3 lights at a time, and inserted these wires into the linker plugs supplied with the lights. Simply press down the buttons and insert the wires into the plugs, matching the color-coded polarity of red and black. The linker plug wires get inserted into one of the 4 light hubs' power output jacks. Pressing these in firmly to ensure a good connection, and just like that, the wharf dock lights are done. To test our progress up to this point, I pressed the rocker switch and the lights turned on, giving a nice even glow on the scene. So far so good. Everything works, and now it's time to light the buildings and the areas on the lift-out part of the diorama. I inserted the module back into the layout at this time, as we now have access to the light hubs from underneath the layout and on top for the rest of this installation process. Turning my attention to the lift-out section of the wharf scene that holds the entire BTS Hyde pulp mill kit, I used a Sharpie to mark the placement of each lamp post. Now, because I am planning to convert this complex of models into restaurants, art galleries, gift shops, I plan to use a variety of different style lights on this scene, and I had that fresh in my mind when deciding the location of each light. Using a 3/32" drill bit, I drilled 8 holes through the 3/4-inch plywood base to accept these lamps. I also drilled 1/2-inch holes in the scene to feed the wires up into the buildings. I took this opportunity to vacuum the scene with the help of a paintbrush to help loosen up the dust. I fed the lights wires through the small holes, pressing the lamps into place. The light posts are not brittle and in fact can be bent just a little to keep them vertical and square to the scene. I drilled 3/32" holes into the freight house using a pin vise in 2 locations on this structure. I then fed the wires for the gooseneck lamps through these holes and glued this into place with CA glue. I placed one of the Woodland Scenics interior LED lights into the freight house, sticking it to an interior wall so that the light would be cast on both floors of this structure. I then pulled the wires from the buildings through the bottom holes in the diorama, keeping them straight and separate as to be organized in groups for the next step in this process. I twisted the lights wires into groups of 3 as before, and inserting these, matching the polarity by color, red to red and black to black, into the linker plugs until all the lights were wired, creating a total of 5 sets of wires with plastic jacks on the end, which will be then plugged into the light hubs installed into the foam diorama. I set the diorama, with all the buildings on top, about 9 inches above the scene, providing safe access underneath to plug in all the jacks into place and stuff the wires into the hole in the foam. I plugged the 5 wired jacks into the open hubs that remained on our light hubs, one at a time, making sure that they clicked when pressed in, just to ensure good conductivity of power for our diorama. I then turned on the lights, making sure every one worked, and they did. The gooseneck lamps, the interior lights, all the lamps had an even glow to them, which I could then adjust with the potentiometers underneath. At this point, I felt a great sense of accomplishment, as everything has gone pretty smooth so far on this project. I lowered the diorama back into the wharf scene, making sure everything fit perfect, and it did. A few days later, I did add an additional light hub underneath the diorama and adding a few more lights on the road that runs parallel to the yard's approach tracks. With that, The wharf has a whole new atmosphere created by these amazing new LED lights from Woodland Scenics. I now plan to install these lights on my entire layout over the next year or so, as the finished effect is simply magic. Someone at Woodland Scenics deserves a raise, because this lighting system is a real winner. It's stunning, in fact, and that's this segment of layout construction on What's Neat.